I'd like to introduce now the concept of rational numbers, which are essentially fractions, but the specific definition that's written here is a little bit more specific, so let's just go through it. A rational number is a number that can be written in the form m over n, where m and n are integers. So m and n are two positive or negative whole numbers, that's what integers are, and the denominator n cannot be 0. Alright, sometimes we write this m and n are integers like this. M and n are elements. That's the Greek letter epsilon, which means is a member of the set of integers. Okay, so that's shorthand for m and n are integers, and n is not 0. Alright, so all we're saying is a rational number is two integers. Let's just take two integers, 2 and 3, and they're divided. That makes a rational number, which we can decimalize. If we decimalize this one, we get 0.6 repeating. Negative 1 over 2, if we have negative 1, which is an integer, divided by 2, which is an integer, that makes a rational number, and that decimal is negative 0.5. Just a regular number 3, that's a rational number also, because 3 can be written as 3 over 1, or 6 over 2. Okay, these are all rational numbers. And we can go on and on. Any two integers divided, as long as the bottom one isn't 0, is a rational number. Now, I've just shown you 3 examples here, but the thing about rational numbers is that their decimals work out nicely. And by that, I mean the decimals either terminate, they stop, or they repeat in a consistent pattern. That's a characteristic of rational numbers. So I can actually take this idea in reverse and say that, if I have any terminating decimal, I can write that in the form an integer over an integer. In this case, 31 over 100. A terminating decimal is a rational number, so it can be written in the form m over n, where the denominator is not 0. Similarly with any repeating decimal. Some of you probably know that if we have 0.313131, that can be written as 31 over 99. You can check that with your calculator. It can be written in the form m over n. It's a rational number. Alright, so we're saying that terminating or repeating decimals in a consistent pattern are rational. What numbers are not rational? Well, numbers like pi, whose decimal goes on endlessly without a consistent pattern. The square root of a non-perfect square, that is an irrational number, not rational. Its decimal goes on endlessly with no consistent pattern. Even a number like this, you might say there's a pattern to this number, but there's not a consistent pattern to the number. We're adding another 1 every time we continue on. So this is also not rational. Now just one more thing about the definition of a rational number. M divided by n, where m and n are integers and the denominator is not 0. I want to talk specifically about why this number cannot be 0. Before I get to that explanation though, let me just remind you about how division is connected to multiplication. When we say 6 divided by 2, and we want to know what that answer means, remember, we can take that statement and we can think that 2 times something, the triangle's my something, 2 times something must be 6. And because we know the answer to this multiplication question, we say that the answer to the division question is 3. Division is just a different way to write multiplication. Alright? So let's take a look at 2 scenarios here. 10 divided by 0 versus 0 divided by 10. If I take the one on the left, 0 divided by 10 equals something, my triangle. If I write that in terms of multiplication, I know that that means that 10 times something has to equal 0. And we know that 10 times 0 will equal 0, and so the answer to this would be 0. 0 divided by 10 is 0. However, if we come over to the right here, and we take 10 divided by 0 is something, and we write that as division, that would mean that 0 times something would have to equal 10. And if you think about that, there's no value that will work here, because 0 times anything is going to be 0. Nothing will work here. And so this is undefined. And that's why having a division by 0, a 0 in the denominator of your rational number, makes it undoable, undefined. And thus we have the restriction that n can't be 0. By the way, you might wonder about 0 divided by 0. What would that be? You would think it to be undefined because 0 is in the denominator, and it is undefined, but there's a different situation going on here. If we write this statement in terms of multiplication, it would be the bottom 0 times something, the triangle, would have to equal the numerator, 0. 0 times what would be 0? Well, there's an infinite number of possibilities. Any number times 0 will be 0. And since there's not just one fixed answer, we say that this is also undefined, 0 divided by 0. But you can see the reason is a little different than a number divided by 0. Just a couple of other tidbits about rational numbers. If I have negative 2 divided by negative 5, you might wonder about the negatives. Well, of course, we can just cancel the negatives, because if we were to type this rational number in as a decimal, we're going to get 0.4. And since the answer is positive, there was really no need for those negatives. So 2 over 5 and negative 2 over negative 5 are the same rational number. Similarly, if you have one negative in the numerator divided by a positive, let's say, if you type that into your calculator, you're going to get negative 0.75. In other words, it doesn't really matter where this negative goes. If it was 3 divided by negative 4, these would be the same. Or if the negative was out front, negative 3 over 4. These three numbers are all the same number. Finally, you should be able to represent rational numbers on a number line. Let's just take a couple. 3/5, which as a decimal is 0.6. So we know on the number line the number would be between 0 and 1. And let's do this somewhat accurately. This means that I have to divide 0 and 1 into 5 equal sections. 1, 2, 3, 4, 5. And so if I move from 0 to the right, 1, 2, 3, this point right here is 3/5. And label it with point A. Let's do another number, negative 1/4. Remember, the negative can be on the numerator or the denominator. This is negative 0.25 as a decimal. And so this number will be between 0 and negative 1. And since we are using quarters, let's divide between 0 and 1 into 4 equal parts. Okay. And now you need to watch carefully about how these numbers go. We start at 0, and the first one over is negative 1 over 4. Okay. The next one would be negative 2 over 4. This one here, C, would be negative 3 over 4. And remember that any number that's further to the left on the number line is smaller than a number that's to the right of that number. So we know that C, negative 3/4, is smaller than negative 1/4.